In this section, we are going to talk about solving inequalities. But before we solve inequalities, we're going to talk about interval notation, which is how you represent solutions to inequalities. Okay, so let's start with the basics. If you have a less than or a greater than sign, we use parentheses to represent that. And we'll talk more about what that means later on. If you have a less than or equal to or a greater than or equal to, we use brackets. Notice the difference is that with the brackets, we have an equal to sign in both the less than and greater than. For parentheses, we don't have an equal to sign. And then for infinity or negative infinity, we use parentheses. Because infinity or negative infinity is not a number, this is a concept that numbers get infinitely big or infinitely small. So because it's not a number, we're going to use parentheses. Okay, now what does interval notation look like? In interval notation, you have either a parenthesis or a bracket on each end. And the first value is the lowest value of a solution set. And then there's a comma in between. The second value is going to be the highest value of a solution set. It's kind of a simplistic way to think about it. Okay, now let's do some examples. For example, we're going to graph x greater than 3. Let's think about this. X represents all the numbers, so I'm going to write this out on words. So x represents all the numbers that are greater than 3. Okay, x is all the numbers that are greater than 3. So it doesn't include 3. Okay, so for example, if I want to say that the number of people at my party who are greater than 3, then 3 is not going to work because it's greater than 3. So it could be 4, it could be 5, it could be 6, it could be 7. But 3 is not part of our solution set because the number of people at the party was more than 3. So 4, 5, 6, 7 all work, but 3 doesn't. So all numbers that are greater than 3. Okay, how would you write this in an interval notation? Well, interval notation is the lowest value, comma, the highest value. So if all the numbers are greater than 3, that means the lowest value is going to be 3. Now notice there's a parenthesis because the number 3 isn't included, but we have to use 3 because 3.01 is a solution. 3.00001, that's a solution because that's bigger than 3. 3.0000001, that's a solution that's bigger than 3. So this represents any number that's bigger than 3 is part of our solution set, but not 3. Okay? Now, the numbers keep getting bigger, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and they keep going further. So the highest value is going to be infinity because the numbers get infinitely big. Okay, all numbers that are greater than 3, 3 comma infinity. We're going to graph this as well. So here's what the graph looks like. You have an open parenthesis on 3, and since numbers are getting bigger, you're going to shade it going towards the right. Okay, all the numbers that are greater than 3. Let's look at the next one. X less than or equal to 6. Okay, so let's think about this. You want all the numbers that are less than or equal to 6. So can the value be 6? Yes, because the equal to sign is there. So you want any number that's less than or equal to 6. So what does that look like? So we could use 6, 5, 4, 3, 2, 1, as long as the number is less than or equal to 6. So and they keep getting smaller and smaller and smaller. So since you want all the numbers that are less than or equal to 6, like 5, 4, 3, 2, 1, 0, they're going to keep getting infinitely small. So the lowest value in the solution set is going to be negative infinity, and the highest value is going to be positive 6. Okay, think about it. If you want numbers that are less than or equal to 6, that means the numbers never go past 6. So the highest value is 6, and it's going towards negative infinity, which is going to be the lowest value. How do you graph this? Well, you have a bracket on 6 here, and we're going towards negative infinity, so it's going to go that way. Okay, now the next one, let's just kind of do it. X less than negative 7. So what does that look like? You want lowest value and highest value. You want all the numbers that are less than negative 7. Negative 7.1, negative 7.2, negative 8, negative 9, negative 10, negative 11, negative 12. The numbers get infinitely small, so they're going to go towards negative infinity, but the numbers never go past negative 7 because it's less than negative 7. So we're going to have negative 7 with the parentheses. This tells you that negative 7 is not included, but even the smallest value less than negative 7, like negative 7.001, that's going to be in your solution set. Next, x is greater than or equal to negative 2. So you want all the values that are greater than or equal to negative 2. So because we can have values that are equal to negative 2, we're going to put negative 2. Now the values of x are bigger than that. So it's negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Greater than, so that's going to get infinitely big, going to go towards infinity. What do these graphs look like? So here, the highest point is negative 7 because you want all the values to be less than negative 7. And it's going towards negative infinity because the numbers get smaller and smaller. Here, we start at negative 2. So we're going to have a bracket on negative 2. And since you want all the values that are greater than negative 2, like negative 1, 0, 1, 2, 3, 4, 5, we're going to have an arrow going that way. Now, this one looks a little bit different. We have negative 5, less than x, less than or equal to 0. Okay, so let's think about this. We want our lowest value and a highest value. The lowest value is negative 5. Unlike x less than negative 7, it doesn't go towards negative infinity. The lowest value here is negative 5. So the low value is negative 5, and the high value is 0. But there's a bracket because 0 is less than or equal to. Okay, so x is any number that's between negative 5 and 0. So negative 5, comma 0. Same thing here. The low value is 3, the high value is 10. And they're both less than or equal to, so we're going to have 3, comma 10, both with brackets. So that's an introduction to interval notation. Now, what we're going to do with this is we're going to take interval notation and we're going to solve inequalities using this interval notation. So inequalities and equations, they have the same basic rules. You distribute, you combine like terms, but there are two differences. So you would distribute, you would combine like terms, that stays the same. Okay? But if you look at your media notes, in solving inequalities, use the same rules as solving equations with two exceptions. Okay, so here are the exceptions. Exception number 1. So now we're on solving inequalities. Okay, exception number 1. The first exception is that in equations, it doesn't matter whether the variables go on the left side of the equal sign or the right side. You can put them on either side. In inequalities, the variables must always be on the left-hand side of the inequality. Okay, so it's important. The variables must always be on the left side of the inequality. The second main difference is in an equation, if you divide by a negative, nothing happens. The equal sign stays an equal sign. But in inequalities, if you multiply or divide both sides of an inequality by a negative, so this is important, you have to multiply or divide both sides of an inequality by a negative, the inequality flips. That means if it's a less than, it becomes a greater than. If it's a greater than, it becomes a less than. So keywords, you have to multiply or divide both sides by a negative, then the inequality flips. Okay, let's see a couple of examples. So example 1. We have negative 3 times 1 minus x less than 12 plus 2x. We want to solve the inequality, we want to write the solution in interval notation, and you want to graph this on a number line. So let's follow the rules of equations to begin with. Step 1 is you distribute the negative 3. Okay, so if you distribute the negative 3, this gives you negative 3 plus 3x less than 12 plus 2x. Now normally, we can put the variables on the left side or the right side of an equation. But because we have an inequality, the variables, they have to go on the left side. They cannot be on the right side. Okay, the variables have to go on the left side. So we get negative 3. 3x minus 2x gives you 1x, and then that's going to be less than 12. Then the next step is you have to move all the numbers or the constants to the right side. So you do that, and you're left with x less than 15. X is by itself, so we're done. Now we got to graph this, and we have to write that in interval notation. So let's do the interval notation first. You want all the values of x that are less than 15. Okay, so like 14, 13, 12, 11. Now where is it going? Is it going towards negative infinity or positive infinity? Well, since the values of x are getting smaller and smaller because you want values that are less than 15, this is going towards negative infinity. Okay, so we're starting here, we have 15, and it's less than, so we're going to go towards negative infinity. Interval notation, the low value is negative infinity and the high value is 15. Okay, that's example 1. I would recommend that for the second example, you try this by yourself. So pause the video, try the second example, and see how you do. And then resume it once you're done. Okay, hopefully you had a chance to work on example 2. So for the second example, we have 4 minus 5 times the quantity 4x minus 1. It's less than or equal to 2x plus 49. All right, let's check it out. First step, we distribute. So what do we distribute? We distribute the negative 5. Okay, don't forget the 5 is a negative. So we have negative 5 times 4x and negative 5 times 1. Negative 5 times 4x, that's negative 20x. Negative 5 times negative 1, that's a positive 5. And there's a 4 in the front. Less than or equal to 2x plus 49. That's step 1, distribute. Second step, same as in equations, you combine your like terms. On this side, we have a 4 plus 5, so I'm going to write that as negative 20x plus 9, less than or equal to 2x plus 49. Now again, in an equation, you could choose to put the variables on the right or the left. It doesn't make a difference. In an inequality, the variables always go on the left side. The constants go on the right side. So we are going to subtract 2x from each side. And in the same step, I'm going to move the constants to the right. So I'm going to subtract 9 from each side. Okay, so what happens? We got negative 20 minus 2, that's a negative 22x. These cancel. You have a less than or equal to. The 2x, negative 2x, these cancel. 49 minus 9 is going to give you 40. Okay, now you have negative 22 times x. So to undo that, you would divide both sides by negative 22. Okay, but look at what this rule says. If you multiply or divide both sides of an inequality by negative, the inequality flips. So because we're dividing both sides of the inequality by a negative, it's going to flip from a less than or equal to a greater than or equal to. And if you reduce this, you can divide each of these by 2. This will give you negative 20 over 11. Okay, so our answer is x greater than or equal to negative 20 over 11. So you want all the values of x that are greater than or equal to negative 20 over 11. Okay, so what does that look like? Greater than means it's going towards positive infinity. So, and all the values are greater than negative 20 over 11 or equal to, so this is the lowest value in the solution set. So the lowest value is negative 20 over 11. Because you're getting greater than, it's going to go towards infinity. How do you graph this? So you graph this with a bracket at negative 20 over 11, and it's going towards infinity, so it's going to look like this. Okay? All right, next problem. We got 3x plus 4. Get rid of this. So we have 3x plus 4. And this is greater than 2/3 times x minus 1. Okay, let's figure this out. Step 1, distribute. So we got 3x plus 4. It's greater than 2/3 times x, which is 2/3 x. 2/3 times negative 1, that's negative 2/3. Okay, do you guys remember what we do with fractions? You want to get rid of it. It's the best thing to do. So to get rid of it, we're going to multiply both sides of the inequality by the LCD. In this case, the LCD is pretty easy. It's 3. So I'm going to multiply this side by 3 and this side by 3. Okay, so what happens? 3 times 3x, that's 9x. 3 times 4 is going to be 12. Inequality stays the same because you multiply both sides by a positive, not a negative. Okay, then we got 2/3 x times 3 minus 2/3 times 3. So the 3 distributes to both these terms. Okay, so we have 9x plus 12. Still got the greater than sign. The 3 and 3, they cross cancel, it gives you 2x. The 3 and 3 cross cancel, give you a negative 2. Okay, now remember, you have to move the variables to the left side. So we subtract 2x from each side. And on the same step, I'm going to move the constants to the right. So I subtract 12 from each side. Okay, if I do that, here's what happens. I end up with 7x, these go away, greater than negative 14. Now the x is being multiplied by 7, so to undo that, we're going to divide by 7. And we're going to divide by 7. So now we're dividing both sides, and I see a negative. Does the sign flip? It doesn't, because we're dividing both sides by a positive and not by a negative. So our answer is going to be x greater than negative 2. You want all the values of x that are greater than negative 2. Okay, now we're not done because we have to write this in interval notation, and we have to graph this. So what does that look like? You want all the values of x that are greater than negative 2, which means negative 2 is going to be the smallest value. So negative 2, and since the numbers are getting bigger and bigger and bigger, it's going to go towards infinity. The graph looks like this. We have a parentheses at negative 2, and since all the values of x are greater than negative 2, the graph is going to go towards infinity. Okay? All right, last example for inequalities. So for our last example, we have negative 3 less than 2x minus 1 over 4, which is less than or equal to 5. It's called the compound inequality because you got two inequalities in one. First step, we want to get rid of the fraction. Well, the 2x minus 1 is being divided by 4, so we're going to multiply by 4 to undo that. But you have two inequalities embedded into one, so you have to multiply the 4 to both sides. Okay, so you have 4 times negative 3, that's negative 12. These cancel, so you're left with 2x minus 1. And then 5 times 4 will give you 20. So we get negative 12 less than 2x minus 1 less than or equal to 20. Now you would solve this just like you would any other inequality. You add 1, but whatever you do, you have to do it to all the sides. So we're going to get negative 12 plus 1, that's negative 11, less than 2x, less than or equal to 21. Then you divide everything by 2. So we're going to get negative 11 over 2, less than x, less than or equal to 21 over 2. Okay, now that's our solution. We still have to write that in interval notation. So what does interval notation look like? This is our lowest value, that's our highest value, because all the values of x are between negative 11 over 2 and 21 over 2. So the lowest value is negative 11 over 2. The highest value is 21 over 2. You got a parentheses and you got a bracket. What does the solution look like? The lowest value in your solution set is negative 11 over 2. The highest value is 21 over 2. And all the values of x are between those two. So the values of x are going to be in between these. Notice we don't go to negative or positive infinity because on one side we stop at negative 11 over 2. On the other side we stop at 21 over 2. Okay, so take a look at these and come to class prepared with questions.